In this video, I want to talk about the binomial theorem and what it is and give an argument for it in terms of counting and permutations. So let's just look at this example, a plus b to the fourth power. So this is a plus b times a plus b times a plus b times a plus b. And one way to figure out what you get when you expand is to notice that when you are expanding this out, what you're really doing is you're picking. So I have four factors, each of them is a plus b. You're picking one term from each of the four factors and then multiplying them all. So for instance, if you pick the a in the first factor, the b in the second factor, the a in the third and fourth factors, and multiply them, you get a times b times a, which is a cubed b. So you get an a cubed b by doing that. And you keep doing that for all the possibilities. Well, how many possibilities are there? There are two options for each factor, right? There are four factors, and then there are two options for each of the factors. You can pick either the a or the b. So there are a total of 2 to the fourth, which is 16 terms in the expansion. Okay. Well, let's think about what you're going to get. So what would be the coefficient of a to the fourth power? The coefficient will be 1, because there's only one way to pick there's only one way to get a to the fourth power, and that's if you pick an a from each of the factors, and there's only one way to do that. So a to the fourth has a coefficient of 1, because there is only one way to pick all a's. Okay, what about a cubed b? So the terms in the expansion are going to have degree 4, right? So a to the fourth has degree 4, a cubed b has degree 3 plus 1 is 4. So now we have to think about, okay, what are all the possible ways to get a cubed b? Well, one way was to do what we just did with the blue choice, which is to make the first choice a, the second choice b, and the third and fourth choices a. But what are the other possibilities? Well, you're picking 3 a's and 1 b, right? So you want to find how many ways can you choose. So how many ways to choose 3 a's and 1 b out of the possibilities? Well, I mean, if you're going to choose 3 a's and 1 b, it's easiest to think about it as out of the 4 options, you're allowed to pick 1 b. So there are 4 options. And so the coefficient, so the answer is 4. So the coefficient of a cubed b is 4, right? Because 4 ways to choose the b. And so the coefficient of a cubed b is 4. Okay, so what about the other possibilities? The other possible terms? You could have a squared b squared. And so what's the coefficient of a squared b squared going to be? It's the number of ways to pick 2 a's and 2 b's, right? And that's the same as the number of ways to pick exactly 2 a's. And that's 4 choose 2. So there are 4 choose 2 ways that's 10, no, not 10, 6, choose 2 ways of picking 2 A's, and then the rest are going to be B's. And similarly, we have for A, B cubed, that's the number of ways to pick 1 A and 3 B's, and so there are 4 ways of picking the A, right? So 4 ways of picking the A. Because it's one of the 4 factors. And then B to the 4th is going to have coefficient of 1, right? Because there's one way of choosing all 4 B's, which is just to choose the 4 B's. And so what you're going to get is A plus B to the 4th power. I write out the possible things I get. A to the 4th, A B cubed, A squared B squared, A B cubed, or did I say that? A to the 4th, A cubed B, A squared B squared, A B to the 3rd, and then B to the 4th power, and then the coefficients are going to be 1, 4, 6, 4, and 1. So that's the expansion of A plus B to the 4th power. And notice that we did that without actually multiplying everything out. Well, how does this work in general? This is a plus 1. How does this work in general if you have A plus B to the nth power? So you're going to have, this is going to have terms A to the n minus 1 times B, A to the n minus 2 times B squared, all the way to A, B to the n minus 1, and B to the n. So those are the terms that are going to be in the expansion, and now we need to figure out the coefficient. Well, we've seen that it's just the number of ways to pick those, to pick that number of n, to pick that number of A's, the number being the exponent. So for instance, in the case of A to the nth power, you have to pick n A's, so there's only 1. For A to the n minus 1, B, there are n choose n minus 1 ways to pick the A. And then for A to the n minus 2, B squared, there are n choose n minus 2 ways to pick the n minus 2 A's, right? Because you're picking the n minus 2 factors out of the n, and so on. And so what you're going to get is you're going to get A plus B to the nth power is going to be the sum from k equals 0 to n of n choose k, A to the k power times B to the n minus k. Okay, so here I wrote it in a slightly different, the terms in the sum are going from, they're going from B to the n to A to the n, right? But, okay, you can also rewrite this as the sum of n, n choose n minus k from k equals 0 to n of A to the n minus k, B to the k. Right, this second way would match the way where you start with A to the n and go to the B to the n. But anyway, it's the same thing. It's this sum. So these two are just a parenthetical remark that these two are the same. Okay. But anyway, this theorem, this fact that you get this, okay, that's called the binomial theorem. Binomial theorem. But by the way, how does it work when you have n choose n? Well, we define 0 factorial to be 1. So this is a definition. So when you have k factorial and you define k factorial to be the product of all the integers from 1 to k, well, that definition doesn't make sense when k is 0. So we just make a separate definition for 0 factorial. We define it to be 1. And that makes sense because, well, first of all, that makes n factorial, that makes n choose n work, right? So n choose n, if you copy the formula, the definition, it's n factorial divided by n factorial times 0 factorial. And then we know that n choose n should be 1 because there's one way to pick n things out of n. And if you define 0 factorial to be 1, then you get n factorial over n factorial times 1, which is 1. So 0 factorial equals 1 is a convenient definition. Also, it fits the pattern, which is, you know, if you have 1 factorial, it's 1, 2 factorial is 1 times 2, 3 factorial is 1 times 2 times 3. So in each one, to go from 3 factorial to 2 factorial, you divide by 3. To go from 2 factorial to 1 factorial, you divide by 2. And so if you think about which one makes sense, if you continue the pattern, you divide by 1, you get 1. Okay, that's not necessarily the best, reason for defining 0 factorial to be 1, but basically the formulas work out nicely if you define 0 factorial to be 1, so why not do that? Okay. And so that's what's going on when k is equal to n, or when k is 0. The formula works. You get n choose 0 or n choose n is equal to 1. And sometimes these numbers, because of the binomial formula, the numbers n choose k are called the binomial coefficients. Because they are the coefficients that show up when you expand the binomial. Okay. So for instance, let's say you had x plus 2 cubed. What is that going to be? Well, the binomial formula says it's going to be, so my n is 3, right? So what I have to do is I have to write the sum from k equals 0 to 3 of n choose k, x to the k times 2 to the n minus k. And this is going to be 3 choose 0, x to the 0 power times 2 to the 3 minus 0, oh, n is 3, right? 3 minus 0, okay, plus 3 choose 1 times x to the first power times 2 to the 3 minus 1 plus 3 choose 2 x squared times 2 to the 3 minus 2 plus 3 choose 3 x cubed 2 to the 3 minus 3 power. And when you when you calculate these out, you get 1 times 8. And then plus 3 choose 1 is 3, and then I have an x times 2 squared. And then I get a 3 choose 2, which is 3x squared times 2 to the first power, and then plus 3 choose 3 is 1. And then I have an x cubed times 2 to the 0 power. And when I expand this out, I get, or when I simplify this, I get 8 plus 12x plus 6x squared plus x cubed. So that's what I get. That's a simple example of using the binomial theorem. There's another way to prove the binomial theorem using induction. But this is a combinatorial argument. It's based on the fact that, we're looking at what you're doing when you're distributing this factored form into the expansion. And just to review, you're picking one term, one term from each factor and multiplying them, and then adding up all the different possible things you get. And so to find the degree, to find the coefficient of a to the k, b to the n minus k, you're picking k a's out of n possible a's, right? You have n factors and you're choosing k of them, and so you get n choose k possibilities, and that explains why the formula is true. Okay. Okay, that's what I wanted to talk about in this video.